Hi everyone, my name is Austin Allen, and this is my final project for Geography 470 Remote Sensing. And I will be explaining how I used NDVI analysis on Landsat imagery to observe pineapple cultivation and growth and how it relates to climate change, food sustainability. So a little background before I go into it. I don't necessarily know how I even got onto this topic, but I learned that pineapples actually thrive and grow better in warmer climates and increasing temperatures, higher salinic soils, and acidic soils. So this got me thinking about how pineapples could even be grown in a changing climate, as we know that temperatures are rising, soils are becoming more acidic, and how acidic the soils are in Hawaii. So I wanted to know if using the pineapple fields on Oahu, if pineapples could become a staple food crop, maybe for a changing climate world. So that leads into our study area. I specifically wanted to focus on the pineapple plantations here on Oahu. And you can see in the top right that are all the areas that I looked at. Those are the lands of the Dole Plantation. Um, Wahiawa is a very important agriculture and cultural region on Oahu due to its expansive, suitable arable lands, its many abundant streams and water sources, as well as the mixture of agricultural commodities that could even be grown here. If you drive through the area, you'll see everything from pineapple plantations to ranches and grazing to beef farms to guava to mango, anything can be grown here, basically. So that adds to its agricultural importance of the area. But we know that before colonization and influence from many plantation and the military influences, the area was used primarily to collect bird feathers. Uh, it was an abundant hunting ground area, as well as Kamehameha's military training grounds were here. But after, it has turned into a lot more grazing, industrial plantations, and the military industrial complex has put its foot in the door here. Um, and we know that these plantations, owners and people who instituted them were leaders of the overthrow of the Hawaiian monarchy due to their stances in politics and interests of American commercial economic gain. So to get the data for this project, I used Professor Chen's Hawaii Moving Average Annual Cloud-Free Composite Landsat data. In the bottom right, this is not a picture of it, but this is just an example photo of what Landsat looks like. As well as I used data from the Hawaii statewide GIS program to get our pineapple fields up in the top right. Uh, this agricultural layer actually is used to zone, and so I know that these lands are all used for pineapple. So my methodology going into this is I wanted to use Envy to start it all. However, while consulting with a grad student and just scouring the web, I found that Esri's ArcGIS Pro actually is one of the easiest ways to achieve NDVI analysis. So to be able to do this way, first you need to add your data. And the data that I chose was the Hawaii MACC, as well as our statewide GIS agricultural layer. So I added both. For the cloud-free composite mosaics, I used 2014, 2015, 2016, 2017, and 2018. And every year I compared the NDVI analysis health to the annual temperature in Hawaii. And I'll show in the results how that interacted with each other. But after I added the data, specifically that of the Landsat, I changed the bands to show just what the human eye would see. So red, I used band 4, green I use band 3, and blue I use band 2. How I know what these bands are is I checked the metadata and these bands were assigned to those colors. So after I got this, I went to the imagery tab in the ribbon. I clicked indices and the NDVI tool. So as well as looking back in the metadata, I used the band 5 for our near infrared and our red band, which was band 4 from before. So Esri does all the calculations for this. It uses the NDVI equation, and it gives you something like in the top right. So this is hard to make an analysis of. So you go to symbology, and then you go to your color scheme. And for this specific project, I used elevation number 10. And that is because the less productive zones are orange, while the deeper green are more highly productive and denser and healthier vegetation. However, there's one last more step. You need to click invert. Otherwise, your oranges are going to be your more productive, healthier areas, and your greens are going to be less. So with invert, it makes it the other way. So greens are more and our oranges are less. So this is our results for 2014. We can see that in the southern areas, not as much production, while kind of the middle it's just kind of average around the board, about half and half. And we can see that when we look at 2014, that it was kind of the bottom of the trend that's going to go up. So we'll see this change. And as we get warmer and warmer, more of these fields are going to be more productive and healthier. So 2015, we see that more fields, as the temperature is starting to rise, it does get more productive. 2016, less orange. 2017, a little bit more orange in the bottom, but overall more denser green orange. And then 2018, it starts to go down, which we can see that in our graph. And because of some things to come, especially with COVID, because some of that data does come from 2019 to 2020, that the temperatures do drop a little bit. And so we can see that those fields are reflecting that. However, when comparing it to 2014 at the bottom, there is still more productivity of the area. So overall, looking at these results, pineapples can be a staple food crop that withstands climate change. Especially in Hawaii, let's say, because of the desirable soils and area, this can be something that can increase our food sovereignty in the area if climate change does get greater and greater and greater. So the average temperature in Honolulu has increased around 2 degrees Fahrenheit. We can see that orange line actually get greater as time goes on. So as I said before, 2013 to 2017, we saw an increase of about 1 degree Fahrenheit, which aligns with our observations. As our temperature increased, I observed higher vegetation and production values. And then in 2019 and 2020, there was a decrease in global temperature values, which aligns with our observations from 2018. So overall, from my observations, these pineapple crops can be a sustainable food crop that is used with and alongside climate change. I ended up actually really liking NDVI analysis overall, and I found it quite easy to use, especially when you have a symbology that makes sense. It can really speed up the process and make your observations that much easier to see. So thank you, and I hope this was interesting.